Lo recogemos. Yeah, you have here. Sí, coged un par, anda. Vosotros que sois de la familia. So, you know, every year we have several sponsors where we like a lot the talks. Checkpoint is one of these sponsors where they have, for example, the collusion of applications in mobile applications. That was one of the most interesting speeches I have seen in my life, because it's very interesting the way several applications in a mobile phone can collude to take advantage of them and send exploits and these kind of things. Today, Gal and Eran, they will talk about the Bashware and introduce by yourselves. You have the, okay, thank you. Go ahead.
No. Test.
Hello.
Test.
Hey, hey.
Yeah.
Hola,
Test.
hola. Okay.
Right. So, can you hear me? Yes? All right. So, hello everybody. Buenos dias. And hola, of course. My name is Eran Vaknin, and with me today is Gal Elbaz. We are both working at Checkpoint Israel. And today we will talk with you about the Bashware. But before, we have some little tradition. In every new city we came, we are making a selfie, all right? So you are going to practice with us in one selfie that Gal is going to take. So let's start.
Wait. Smile.
Smile, right?
Okay.
All right.
Hola.
All
Okay.
right. All right. So good morning. And today we'll talk, as I said before, on Bashware. Bashware is a recent publication we had a few months ago in our team. We are both security researchers. We are doing some vulnerability assessment and security research in our team in Israel. We found a lot of vulnerabilities in the past few years, and this is the most powerful and amazing one we had. So let's move to the next. All right, so before we can start, let's us introduce ourselves, all right? As I said before, we are both security researchers. We are both fans of Ronaldo. We came here to see also a football match of Real Madrid, all right? And we both have LinkedIn and an email, so if you have questions after this session, you should contact us immediately and we'll answer it just by time. All right, so this is today's agenda. We have the WSL overview on risks. We have the Bashware research goal and the Bashware deep dive, which Elbaz will take. We will do some demo, and then we go to the Q&A. And if we have some time, we will also have some bonus presentation and slides. All right, so the main core of today's session is WSL, all right? I don't know if all of you is knowing, but WSL, it's a new feature developed by Microsoft to enable Windows 10 installation to have the core functions and commands of Bashware inside Windows instances. Actually, Windows want to do this because they want to eliminate the use of VMware and VirtualBox Linux instances inside Windows. So the only thing you need to do in order to start typing some bash commands inside your Windows installation is just open the CMD, pop up new shell, and just type bash. And then you will be able to execute arbitrary commands inside your Windows 10 installations. So to the next step of the technical stuff, Elbaz will take it from here. All right, so good luck.
Okay, muchas gracias, amigo. As Eran told you about WSL, this is far more than having the familiar bash, meaning this is a whole new components that build from user mode and kernel mode that enables you to run any Linux ELF binary, 64 I mean, only 64, upon Windows. Meaning this is a whole isolated environment that runs within your Windows and it just talks and communicates with itself. So basically, running Linux upon Windows, it was a fairy tale 1 year ago. And now it's not actually that we have the Linux kernel hidden inside the Windows. It's actually a couple of components that enables us to run the Linux environment isolated and communicates only with itself. And so we're going to go over and explain a little bit about the components and understand how this new feature that comes with a lot of new technologies and with it a lot of risks and problems. But also this feature is really, really good. It's new technology. It enables you to run Linux executables upon Windows. So as you can see, we have the bash.exe in the user mode, which is just basically the launcher. When you launch bash.exe, it communicates with the LX session manager, which is just a high privilege service in just terms of security. So the high privilege session manager is the only one that can communicate and say to LX core, start the Linux instance. Well, LX core is very important part of the WSL feature. As its name indicates, this is the core of the product. This is the driver that emulates the Linux kernel. And basically, what Microsoft does, they cannot take the Linux system calls because Linux is open source. And if Windows will use an open source, they will need to open their code also, and then people will hack them. So what they do, they took all of the POSIX system call and implemented them themselves. Meaning there's a LX core is a driver that emulates all of the system calls that Linux. They just write it and write it by themselves, implemented it in Windows. And he is the only Pico provider. We'll explain a little bit later, just to remember what is Pico provider. And he's the only one that can create, as you can see, create and communicate with the Linux instance. The Linux instance, as you can see in front of you, in the orange stuff, this is a Pico process. This is different from a regular Win32 process, from an anti process, because this is a new type of process that introduced in this technology. We're going to go and explain a little bit more about this process. But as you can see in front of you, the only one that can create and communicate with this type of process, new type of process, it's only LX core. And by that, it's like an isolated environment that runs within your Windows because it can only, he's the only one that can create and communicate with those Linux instances. So what is this new type of technology, this Pico process? So actually, it's not kind of new because this is an old technology that was from Project Drawbridge when Microsoft wanted to run an Android application upon Windows Phone. The problem is that no one uses Windows Phone, so they shut down the project, but the technology still exists. As you can see in front of you, we have a regular anti-process. This is the process that all of you know. They have all of the structure, the regular one, the PEB, the tab, the process environment block, thread environment block, shared user data, everything regular. As you can see in front of you, we have minimal process, which is like the same process with the same capabilities, but it doesn't have all of these members. It lacks all of these members that used to identify Windows process. And Pico process, it's basically a minimal process with associated Pico provider. And who is the Pico provider? As you can see in front of you, it's LX core. So this new type of process, he has the same capabilities, he can do whatever anti-process can do, but he's lack all of this structural number. And here it's what the problem relays. This is what the biggest issue that we took advantage in order to do something malicious, to show that how easily it can be manipulated, because this is a regular process in everyone, but because he is lack of all of this structure, no one could identify him. So security products and monitoring tools and everything that used to deal with anti-process, they know how to deal with it. They usually catch it by going to the tab, from the tab. By this way, you can catch and communicate with the process, see what it does. But the minute we have this new type of process, and his lack of everything, the minute he does something, none of the security tools know how to catch it. Doesn't know what is running upon the system. So we have a new creature with the same capabilities, is the same dangerous as a regular anti-process, but no one could catch him. So what basically happened, it's the Pico process, this technology, as I told you before, the only one that can create this Pico process is the LX core. He's the only Pico provider. He's the only one that can create and communicates. And how this communication is happening. So in front of you, you can see two system calls. One is from Windows, the regular dir, the one that showed the directory tree, and the accompanied one from Linux, it's the ls. So this is what happened when we do Windows system call, regular on Windows. It goes directly to the kernel. The kernel intercept the system call, know what to do, which function to call. This is the regular process of what's happening when we perform a system call. But now, when we do ls, which is a Linux system call, which will be performed from the Linux environment, from within the Pico, what will going to happen, you can see it goes to LXSS, meaning LXSS is same as LX core, and LX core, the emulated Linux kernel, is the driver that is responsible for communicating and creating, and all of the core of the product is relays in him. He goes directly and calls it directly, meaning it doesn't have anything to do with the anti-kernel. And why it's the problem? Because most of the AVs nowadays and security products, they sit right there between of the system call and the kernel, and they can intercept and block something if something bad will happen. If they see that something is malicious, they can block it. But now, if it calls it directly and it doesn't communicate with the kernel, it's another problem. So now, after we understood a little bit what is this WSL, what is this new feature that allows us to run Linux upon Windows, let's go a little bit history. So when this feature just came out with Windows 10, there was a lot of compatibility issues because this new technology of this Pico process and LX core and all of the stuff that we talked about, it doesn't really work well with all of the Windows AVs nowadays because they didn't know what happened, didn't know what's run on the system. A lot of false negative, a lot of problems happen. So, and a lot of also, it is a big feature with a lot of new technology. So they had a lot of problems. People were getting crash dumps and blue screens all day. So they decided to take a step back. And Microsoft declared this feature as a beta. And they opened the GitHub page, and people could upload their crash dumps and talk about problems, and they actually communicate directly with the developers of this product. And by that, they let the community help and assist in building this feature. And it was really good, and people really cooperated. And after some time, this feature was beta no more. Now it's official Windows feature from any Windows 10. But because of a lot of security researchers around the globe and also people had problem with this feature, and also security researchers saw the potential of running Linux upon Windows. It's like giving us work. So a lot of people starting pointing out problems, finding vulnerabilities. So Microsoft decided to take a few security measures because in the beginning, every Windows 10, you can just type in bash, all of the environment was on by default. So all of the drivers were loaded, all of the environment was up, everyone can run Linux instance upon your Windows 10 without even asking you. So after a lot of research around the globe, pointed out and people talk about problems that was in WSL, they decided to take those three security measures. So now all of the components are still on every Windows 10 version. They're there, but they are not enabled by default. So if you want to enable this feature, first of all, you need to go to the Windows feature on and off, enable the feature. It shows you how it's running in background, downloads a lot of stuff. Then you must work on developer mode, which Microsoft and Windows warns you, which is a very risky mode because in developer mode you don't know what is going to happen. It's very, very dangerous, etc., etc. And in the end, you need to use one of another components of WSL, which is called LXRun, which is the one of the WSL features that is the one that's responsible for downloading the Linux environment. So all of these three steps, this is the three steps that we need to do in order to enable this feature. Meaning after these three steps are done on your Windows computer, you can freely run any Linux instance, any Linux elf that you would want, and this is the environment will run exactly. Okay, let's go. Okay, so now after we understood what is this WSL, let's talk about Bashware. So what is Bashware actually? Bashware, it's like, as its name indicates, it's bash, like the bash that we talked about, and where? For malware. Because what we basically wanted to do, we took this underlying mechanism and we took advantage of it in order to run any malicious code that we want. So let's talk high level. We can take any known and signed Windows malware and run it completely undetected and hidden from all of the AVs using this tool. Okay, when we found it, all of the AVs were vulnerable, even Windows Defender, which is funny because it's their own feature. But basically what Bashware does, this method, it can take any known malware, it sets up the environment, and it runs the malware from within the environment. And by that, it makes him completely hidden and undetected. So why we wanted to do this, what is the goal of the research, actually? So people were, as I told you before, people were pointing out problems and talking about the security risk and a lot of vulnerabilities, and people were talking about the dangers of running Linux upon Windows, but it was all theory, and no one really did it. So we saw how easily can one manipulate the system and turn up the environment, run any, and use it in order to do malicious stuff. This is what we do. So we decided to take a step and take all of these theory threats and make them a real threats. And by that, people would see, when people see in their eyes, they believe there's something malicious. And after we did this research, a lot of AVs around the globe, they fixed this problem. We showing in our blog post also, we added how to mitigate against this problem. And also Microsoft was very responsible. They published a set of API, Pico API, for supporting this Pico process, because it cannot be monitored before. But people done a lot of good work. But we wanted to show, and before people would take advantage of it, we decided to take it and all of the threats and make them real. So let's go deeper and understand what Bashware actually does. So Bashware consists of 4 major steps. The first 3 steps are basically the one that we talked before. When Bashware finished those 3 steps, all of the Linux environment is set up. We can run any Linux instance. So let's go quick over those steps. The first step is enabling the WSL feature, meaning, I want to explain, let's take a step back. Bashware can go to any Windows 10 computer, and what it does, even if the environment is on and even if it's off, it can set the environment by itself, run the malicious content, the malicious payload that you want, and then sets the environment down. So basically, this risk is potentially aiming all of Windows 10 users around the globe. We're talking 400 billion, as we checked last time. So this is really, really affecting a lot of people. And how it does it, how Bashware does it. So basically, all of the drivers, first of all, are on the system, but they are not loaded. So all of these steps are doing Bashware does without even user interaction, meaning the moment I run it, the user doesn't even know. We load the driver, resets the environment, we run the malicious payload, and we take it down. The user doesn't even know that they have a Linux instance running in his computer. So the first step, loading the WSL driver, we're using a simple utility running in the background that loads the driver. This is one of Microsoft utilities. Very legitimate, very easy. Once we do it, the driver are loaded, meaning LXCore, LXSS, all of the components. The second step is the developer mode. So as I told you before, as a security measure, Microsoft decided to that this feature can only run if the user is on developer mode. But during our research, we saw that developer mode, it's only 2 registry keys that set from 1 to 0. We saw that the driver is going, because if you turn off developer mode, you see a lot of stuff is running in the background. It show you a warning, it tell you how you want to turn on developer mode, and you see a lot of stuff running in the background. It's actually, I don't want to say, but I say it's a bullshit, because it's only 2 registry values that we set from 0 to 1. So Bashware just know when the driver try to check the developer mode, sets the values to 1. There's no, they doesn't even check who's and what privileges and who's setting those values. So we just set them to 1. The driver happy, he thinks he's in developer mode, and then we turn the values down. So the second one, developer mode, can be easily manipulated, tricking the OS. The third one is we need to install the Linux file system, which is just, as I show you, something running, a lot of calculating. It shows you that is downloading the Linux environment. Basically, it's one file, compressed file that's coming from Windows servers. We found vulnerability, we'll show you after, in this process of downloading this Linux file system. But basically, Bashware can work also offline, because it can take this Linux file, compressed file with all the file system, and just compress and deploy it to the appropriate directory that WSL works for. And after the 3 steps are fully completed, the Linux environment is fully on. So meaning we can run any Linux instance, any Linux binary that we want upon our Windows machine. So now, after we have all of the facts, all of the environment in front of us, we started to think, okay, we can take advantage of it. So Linux malwares written to run upon Windows, this is not something that didn't happen before, because this is something new. People didn't, if I'll tell someone that I'm gonna run Linux upon Windows, he will think I'm stupid. So there aren't Linux malwares written and aiming for Windows. And Linux malwares world are also very, very little. We know that the biggest and the most major malware world is upon Windows. So we thought how we could take advantage of it. So what do we know? We know that the minute that we are running Linux instance, we're running Linux binary, ELF binary, upon our Windows machine, it runs as a Pico process, and is run completely hidden. So what we thought about, we can take the Windows malware, just convert it to Linux ELF, sets up the environment, and run it from the Linux environment, and by that is completely hidden. So we have Wine, which is a great open source project, which basically does everything we needed for this project. It takes the Windows exe, and it built a Linux ELF just from the system calls. And why it's good for us, it doesn't emulate anything, doesn't set up an environment by himself, it just builds another ELF from the same system calls, from the NT process, from the Windows exe, and by that we know that after we run from the Linux side, all of the Linux system call are gonna run from the Pico side and be completely hidden. So we just use Wine, we convert the payload that we wanna run, and it's completely hidden. So, okay. When we first published Bashware, it was talked all over the world, it was really, really big. And most of the AV and products, they cooperated, and they said it's really, really a big problem, and people and companies contact us, and we explained how to mitigate against the problem. But there are several people that said that it doesn't work. It's not aiming something, and just This quote is from Motherboard magazine. It's a big magazine that did a blog post about Bashware after we published it. And this particular quote is very important to me because it shows me something that people didn't understand when we published this blog post. So as you can see, senior vice president of some AV, as you can see in front of you, Symantec, he said, based on this WSL architecture, semantic scanner, machine learning, and protection technologies are designed to scan and detect malware created using WSL. Really? Okay, so why this quote is very important for me, because it shows me that this guy doesn't understand the problem, because what we are talking about is a new technology. It's a new creature running upon Windows that we took advantage of in order to run our malicious code. So even if you have all of this AI engine and behavioral analysis and you know that something malicious happened, it doesn't help you because, let's say, for example, something is running on your computer. Let's say ransomware. It runs, it opens files, encrypts them. It's very easy to, I don't know, anyone can identify that something malicious has happened. Something is running and encrypt my file. It's malicious, okay? I don't need AI engines or behavior analysis. But even though if you can recognize and you can see that something malicious is happening, but you can't stop it, what does it work? Because the minute that they can see that something malicious is running on the computer, they will try to catch it. But the thing that we run, it's a Pico process. And all of the AVs nowadays, they don't know how to communicate with it. Because if you didn't add the Pico API to your tool, to your security product, if you don't have the Pico API, you cannot monitor it. So even if you can see something malicious is happening, but you can't stop it, what is even worse? So we're gonna show we're gonna show a quick demo, and by this demo, we're gonna show you how Bashware really works. We're gonna show 2 scenarios. Eran will put us the video. זה שם בתיקייה. תסתכל פה. Just a second. Okay. So we're gonna show now 2 scenarios. We decided to use Symantec because they annoyed us. And the first scenario, we're gonna show a regular Windows 10 PC. Okay. The first scenario is a regular PC without Bashware. We're gonna show you what happened when we have antivirus running. You can see in front of you is up to date, no problems. And we're gonna show you what happened when you're trying to run malicious malware upon Windows. What should happen and what is happening in any AV. So we use Netcat, which is a malicious backdoor. This is Netcat with reverse shell. It's malicious. I think every AV nowadays will recognize this as something malicious. This is actually a backdoor. So what's it gonna do now? We're gonna show you what happened when I will try to run Netcat upon a Windows 10 PC with AV running upon it. So I'm gonna take Netcat and gonna run it from the PC and gonna see what's gonna happen. And boom, blocked me. As you can see, Symantec fast and easily recognize Netcat as something malicious, prevent it from running, and doesn't let you run. So this is what usually need to happen when something malicious is trying to run upon your computer. So this was the first scenario. And now we're gonna go to the second scenario, which is the same machine, same environment, but now we're gonna use Bashware. So now we're gonna see. I'm gonna show you first that Symantec is running also. And I'm gonna take the specific Netcat, and I'm gonna show you what is happening when trying to run it. So first of all, let's see again. We have Symantec is running, is up to date, no problems. First of all, I wanna show you, I'm gonna use Netstat to show you that nothing is listening. on port 1337, which is the port of the hackers. And if you see this port running, something bad is happening in your computer. So as you can see, nothing is running and listening on 1337. Now Bashware is running. So usually when Bashware runs, it's run without any user interaction. But this time we wrote something very, very simple to show you what is happening behind the scenes, all of the steps that Bashware does. As you can see in front of you, the first step, checking if the feature is on and off. If it's off, just enable it. The next step is the developer mode. Easily enable the developer mode, deploying the system. And in the end, you can see the payload that we are running. So the payload that we're running, as you can see in front of you, is netcat, the same netcat, listening on port 1337 for a reverse shell. So now you can see it's running. Nothing is stopping us. Nothing is blocking us. And let's go even more. Let's see if something is really listening. So I'm going to use this command. And now you can see this port is listening. Let's do even more. Let's take this IP. Let's see that everything is running. And I'm reminding you, Symantec is still running, is up to date. No problems are detected. Now I'm going to go to my computer, Gal. I'm going to connect to the backdoor on the computer with the same netcat. And as you can see, boom, we have a shell on the computer. Symantec, no one stops us. And I'm going to show you the username. This is SecTeam. I'm going to go out. This is my computer from the attacker, Gal. Hola. Okay. So this was the demo. It was really important for us to show that it's really, really easy. How can one take and easily use this? You can see Symantec is still running. And it was important for us to tell the community Bashware was kind of a wake-up call, because we saw how easily one can manipulate and take this underlying mechanism, which is very, very powerful feature and really, really good, and take advantage of it in order to do malicious activity. Another bonus slide, as I told you before. We found a double privilege elevation. What it means, in one of the installation process of WSL, one of the steps, it downloads the file system from within of Microsoft's computers. So we found USC bypass, and it's kind of funny because from this USC bypass we can get root on the Linux side and also admin on the Windows side. So we have two privilege elevation in one bug. So what basically happens, as you can see, the user, in order to run the WSL, he connects to the Microsoft server, downloads the lxss*gz file, which is the file that consists all of the Linux file system, and then he extracts it and deploys it to the WSL file system, and the one that the user will afterwards use in order to run the WSL. So as you can see, the attacker just can sit in the middle. It's a simple race condition bug, because as when we saw this process and we're doing our research, we saw that what WSL basically does, it downloads the file. It does a lot of calculating, SHA-256, made a lot of hashes, checks the digital inside, and after it finishes, it opens the file, extracts it to this appropriate folder. But there's a really, really small time gap from within that they finished checking all of the security checks, checking the hashes and the file they downloaded, that it didn't got corrupted or changed. And there's a few lines of code between they finish this and then between they starting to deploy it and extract it. So in this little time gap, we just replace the file with our malicious file system, consisting of some scripts that will run anytime that the Linux environment is run. So from a high privileged directory, so we instantly get in root. And also, WSL, I don't know if you know, beside of having a Linux environment, it also takes all of the Windows environment and mount it to your Linux environment, meaning all of the C directory, all of the Windows the System32 driver, all of the Windows environment is accessible from within of the Linux environment, meaning I can do cd, ls, go to directory, all of the Windows. So, but also they want to do it secure. So they tell you you cannot go to all of these high privileged or dangerous places without high privileges. So Bash runs, it inherits the user token, meaning if I will run Bash as admin, the Linux side will have capabilities of an admin in my system, meaning the Pico process can do anything that the admin can do. So what basically happened, and you will need to run WSL in admin sometime because you cannot use all of the network features, you cannot go to a lot of places. It tells you if you don't have admin privileges, you cannot do it. So the minute that our code identified that we got the admin token, and so we can basically write any code that we want to any high privilege directory, and by that getting also admin privileges on the Windows side. So we have both root and admin from one simple race condition bug. So that's basically it. That was our research. And if you have any questions, something that you want to ask us, this is the time. Thank you. Gracias, mucho gracias.
Thank you all.
My God, I feel really awful right now because of this research. A quick question: do you have access to the LSA secrets and whatever is in protected in memory or whatever from the Linux? Oh my God.
You have all of the capabilities that a regular anti-process does. You can do anything, just it depends on your token. If it runs under admin, so you have admin rights. If it runs the system, you have system rights. And one can easily take, just show you how we can take admin rights. So,
but it's virtualization, or it's like a SigWin or whatever? Yeah, you have BT access to the process, or you are in a virtual...
You have any access to everything.
Oh my
it's
God.
the same process.
Okay, I see. Questions? Many questions. Sorry. Okay, I will take one. Si me echas una mano. Selvi primero. Aquí.
Hello.
Hello.
First, congratulations for the talk. I think it was very interesting. It's something that came to my mind when I was listening to you was that obviously you are bypassing the scan that the antivirus does when you open a process, because it's like in a second layer, it's behind the Pico process, right? But I was thinking if Netcat, it's like not very noisy. Have you tried to do the same with other more noisy pieces of malware that could trigger other, let's say, behavior signatures or something? Have you found, and if so, if you have tested with several antivirus firms, I'm not telling you to say the names, but how
Don't worry,
are we
they are
protected?
sponsors in the event, no problem.
Based on your experience testing this. Thank you.
Thank you. Great question. So actually, in our main blog post, we have also a demonstration of running and ransomware, which is the most behavior screaming that there are, because we wanted to test everything, and as you said, we tested a lot of malwares, also ransomware, and other stuff, and it doesn't even matter because if it doesn't support the Pico API, doesn't implement it in your product, you will never be able to stop it. And it's okay. When we tested it, we bypassed all of the AVs, but it was a long time ago, and we did a responsible disclosure. We talked with Microsoft. Bashware was a wake-up call, so a lot of AVs around the world was talking with us. In our blog post, we demonstrated how to mitigate against this. Also, by simply adding support to the Pico APIs. It was always there, it was undocumented at the beginning, but after the people were pointing out problems, so Microsoft decided to take a step and they did a blog post about how to add and support to this Pico API. Also, we suggested a simple way of monitoring the developer mode registry values, and by manipulating them, if you see someone that isn't one of Microsoft process, that one that should and need to enable developer mode, you see someone that is strange, that's trying to turn developer mode, we block it before. So, of course, before we published it, we took like half a year because we needed to fix our products before and talk with AVs around the world. We couldn't talk with each and every one, so Bashware was our responsible disclosure, let's say. But yes, we tested it, and you can see in our main blog post, you can type Bashware, and you can see the also demo videos of running ransomwares within this using Bashware.
Tenemos tiempo para más preguntas. He visto que había alguien más ha levantado ahí, pero no, ahora no veo la mano. Si no, José mi quería.
Hi guys, here. So great research. Question for you. So this is theoretical. How do you see that this can be real? Like from cybercriminals using this technique to attack like normal cybercrime campaign or a targeted attack or something like that? And it says that maybe I was coming a bit late. Is there any other requirement besides just executing the executable, or is just without clicking and then you are running any malware in the Linux part of the Windows machine?
So,
Thank you.
No problem, thank you. So first of all, no, okay. So first of all, about using it. So when we first published Bashware, we saw a lot of malwares that we started to monitoring stuff, and we saw a lot of malwares that we caught in the wild trying to do the trick with the developer mode. We didn't got in and checked what they're trying to do, but in theory, it can be done. It can potentially be easily manipulated in order to hide, and it's like perfect for rootkits, perfect for, I don't know, if you want to hide your malware, you don't need to worry about signature based, because it's an ELF, and all of the signature based nowadays it's working about the PE of Windows. They don't know how to dissect the ELF, and so in terms of behavior and signature, it's actually perfect for hiding malwares, and perfect for rootkits and this kind of stuff. And as I told you, when we first published it, we saw a lot of malwares. We caught a lot of malwares trying to trick the OS with the developer mode and trying to use one of the features. We saw that people in the world are really trying to do it. And talking about requirements, when we did it, it was very, we want to focus on the main idea about the Pico process, and people had support, because for us it was important and risky enough for telling all of the AVs around the world, wake up, add support to this. But in terms of in the requirements, one can easily just, all of the drivers on the system, you can do it in a lot of ways. You just don't need to do it like we did. You can load the driver dynamically, you can bring it with yourself, trick the developer mode, turn it on if you have high privileges. So it can be done in a lot of ways, like enabling the Linux environment. The point that we wanted to emphasize was the part that the Pico process is the same process with the same capabilities and should be treated the same as any process. So it can be done in a lot of ways, in a lot of different scenarios.
More questions, más preguntas, more questions, manos que no veo. A quick question, can you, in the best scenario where you have the development mode and everything set to run, can you invoke from a Windows standard PE the ELF as a new thread or whatever?
Can I create Windows instances from the Linux environment? I think in the past you could do it, but after I think several of other researchers around the globe, Alex UNESCO and other people pointed it out. So I think they disclosed this problem. Yeah, it's really just the beginning of it because it's a whole big and new feature, and we have all of this Linux system call implemented from zero, meaning 700 kilobytes of new attack vector, which is gold for people like us. And as we speak, actually a few months ago, another researcher from Israel demonstrated how we found a vulnerability in LX core, and by that he was able to run Linux exploits upon Windows and running everything. So this feature is great. It comes with a lot of feature. I use it. It's very, very easy. It eliminates the need of having fire up a Linux VM because I can type in bash and can do whatever I want. I can compile, write code, everything. It's amazing feature, but with new feature and new technologies, there's a lot of problem, and people are still doing it and researching it every day and doing a lot of amazing stuff, even running Linux exploits upon Windows.
Last question.
Sorry again. So I was wondering, from this Bashware, you are running normal malware, the typical injection in a remote process and all this, do you think that works? Or, I don't know, I was just wondering.
If you want to inject to a Pico process or from Pico outside?
I mean, malware normally injects, creates a process or injects
Yeah,
in
it
a
works
remote
perfectly.
process.
It's the same process as anti-process, but it doesn't have all of its members. But it can do everything. It has the same capabilities. Anything that Windows process can do, Pico process can
So
do.
it just works. Okay.
Yeah, the only limitation it's about creating it, creating the Pico process, because the only one that can create it is the LX core, the Pico provider. So by enabling the environment, and we can create those Pico process, but we can't create it directly. So we use the LX core.
So the general challenge is to actually turn out or turn on the system and enroll all of the features that need to be updated and turn on, right? This is your mission. And then when you will success this, you can do whatever you want as a regular malware.
Thank you so much. Disturbing.
Thank you, guys. Muchas gracias. It was a pleasure.